So as we move on, we're going to take a look at how we can conduct a hypothesis test based around the correlation coefficient. As a reminder, when we do conduct a hypothesis test, we take a sample statistic and we try to make an inference about the population parameter from there. In this case, there are two versions of the PMCC, the product moment correlation coefficient. We have R, which denotes the sample correlation coefficient, and we have rho, which will denote the population correlation coefficient. We don't have the whole population, and we rarely have the ability to take a census and to calculate rho, which is the correlation of the whole population. Instead, we'll use what we have, which is the sample data. We'll calculate a correlation coefficient from it, and if it's strong enough, we'll make an inference, draw a conclusion, which says that actually this sample statistic seems to give us some indication of what might be true about the population parameter. The value of R that we calculate is giving us some insight to the value of rho for the population. Okay, so let's have a look at an example. Here we have a sample, we have some data from the large data set about maximum gust and the daily maximum relative humidity. Now this is for Leemings. Now, as you'll no doubt recall, we always start our hypothesis test with our hypothesis statements for the null and the alternate. The null hypothesis for a correlation hypothesis test will always be rho equals 0. This indicates that there is no correlation between the two variables. The alternate hypothesis actually depends on the context of the question. In this question, we were asked whether there was evidence of positive correlation. So the alternate hypothesis is rho is greater than 0. As always, let context drive the question. In part A, we're asked to find the product moment correlation coefficient. I think you know how to do that, so I'd rather just attempt this question in the normal hypothesis testing technique, and I would have answered both A and B in doing so. We're asked to test at a 10% level of significance. So I have a significance level here, alpha equals 0.1. The other variable that's important, and you'll see why in a second, is that we know the exact sample size. This is bivariate data. Each data point has 2 components. So actually, there's only 8 pieces of data. There were 8 different days in May that we collected this data for. In this question, n equals 8. It was important for me to know both the significance level alpha and the sample size n, because we're going to refer to the tables for a critical value, and that is how we're going to decide whether or not our sample correlation coefficient is significant, whether or not it's strong enough to indicate that the population may well have some correlation. We're going to refer to the tables. So we looked at some tables back when we did binomial hypothesis testing, and there are some specific tables available for correlation coefficients. These can be found on page 37 of the formula book. To use the tables, we first need to know what significance level we're working with. We're working with a 10% significance level, so we're going to look through the column for 10% significance level. We also need to know the sample size. In this case, the sample size was 8, so we're going to read across from 8 in the sample size column, and we're going to cross-reference and find the coefficient that we're going to use as our critical value. So as we scan along, we see the coefficient we're looking for is 0.5067. Okay, so that's going to be our critical value. If our sample correlation coefficient, if our value for R is stronger than that boundary limit, is stronger than that critical value, then we have a significant result. We will have evidence to reject H0. So getting back to our example, I'm going to quickly give myself a representation of the correlation coefficient spectrum. I'm going to mark on the critical value, 0.5067. Once again, anything beyond this, any R value that I calculate that is stronger than my critical value will lead me to reject H0. Well, if we put these values into our calculator, we get a value of R, which is 0.1149. So quickly to indicate where this is on the spectrum, it's here. It's on the outside of the critical region. It's not as strong as our critical value. So we don't have enough evidence to reject the null hypothesis. We don't have enough evidence to convince us that there's actually some correlation between the population data. So we'll make our usual conclusions here. There is not enough evidence to reject H0. That's the mathematical conclusion. And then there's not enough evidence that there is some correlation between the daily maximum gust and the daily maximum relative humidity. Very similar steps to the hypothesis test we've seen before. State the hypothesis, significance level, use that to construct a critical value. We'll then calculate our test statistic, which in this case is R. We'll make a comparison, and then we'll draw our conclusions. And this is everything you would need on the paper to get full marks for a hypothesis test. So let's have a look at another example here. So this time round, we've already been given the test statistic. R's already been calculated for us. We'll go ahead and read through to decide what type of hypothesis test we're doing. If you read carefully, you realize that the scientist believes there's no correlation between the masses. We have no indication of whether we're looking for positive or negative, so we're actually just going to look for some correlation. We're actually just going to set the alternate hypothesis to rho does not equal 0. This is then a two-tailed test. If you remember with the two-tailed test, we take our significance level and we split it in two, so that some of it is represented at the bottom end and some of it is represented at the top end. Some of it is in the bottom tail, while some of it is in the top tail. So we'll do a similar thing here as well. The significance level divided by 2 gives us 5%. Let's go back to the tables. This time we're going to look in the 5% column. And we know we need a value from this column that matches up with the n value. This time, and in this case, n equaled 30. So we're going to scan down until we get to a 30 in the n column. And once again, read across and see what value corresponds. In this case, the critical value is 0.3061. If our R value represents a stronger correlation than 0.3061, we will conclude that we have enough evidence to reject H0, and we have evidence to suggest that there may actually be some correlation between these two variables within the population. So after we've looked that value up, we want to make use of that on our diagram. Now remember, this was a two-tailed test. We don't know, or we may not have known, whether our R value was going to be positive or negative. So we've got the critical value for both ends of the spectrum. So actually, I've looked up the positive value, but we need to consider both the positive and negative 0.3061. So here's my correlation spectrum again. I'm going to draw in the critical values and shade the critical regions. If our R value was anything greater than 0.3061, it would be in this region on the right. And if it was anything less than negative 0.3061, it will be in this region on the left. The R value, don't forget, was given to us in the question. I've ignored it up to now, so I can get to this point naturally. The R value is negative 0.45, and it is indeed in the critical region. It is a stronger correlation than negative 0.3061. So we do have evidence to reject H0. We have enough evidence to reject H0. Now this was the scientist's claim. In context, we have some evidence to suggest that there is some correlation between the masses of the two reactants. As always, we make sure to make this contextual conclusion, and to use as much as we can the phrase that was given to us in the question. Be careful not to start talking about negative correlation. We weren't testing for negative correlation in our original hypothesis. We were testing for no correlation and some correlation. So I just continue to refer to there's evidence that there is some correlation between the two variables. So this is the hypothesis test and the structure I'd want you to use. State your hypotheses, the significance level, and the value of n. You're going to look up your critical value in the tables using the significance level and the value of n. From there, you should really make this diagram, draw a sketch for yourself so you can visually see what's going to happen. Calculate your value of r, make a comparison, and then draw your conclusions. Hopefully, the hypothesis test technique is becoming more familiar to you now that you've seen it in multiple different instances. Practice some of these questions. So take the opportunity now to go and practice some questions on conducting a hypothesis test on a correlation coefficient.